Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet typically every second week of the month. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. As we always do, a big thank you to our sponsors, the .NET Foundation for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space, as well as the recording. If you're joining us for the first time, please keep in mind participation is encouraged, and like I always say, the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. Keep in mind that this user group serves as a platform for sharing knowledge, which means that we have a technical presenter and we have people that are willing to listen and absorb and ask questions. So with that said, always feel free to ask questions. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise that's unexpected. And we want to keep it casual but organized, meaning try to keep it as casual as possible, but at the same time, we want to give our presenter enough time to go through the slides and the demos. And lastly, the meeting is being recorded and will be posted on YouTube shortly after the editing process. So for tonight's feature presentation, we have MLOps plus DevOps plus Kubernetes equals love by Annie Talvasto. Annie's an award-winning international speaker and leader. She is everything Kubernetes, cloud native. She's spoken at various international conferences such as KubeCon, CloudNativeCon, Build, Ignite, and multiple others. She's the Cloud Native Computing Foundation Ambassador. She's also an Azure and AI MVP. And she's the program chair for the Secure AI Summit. She also hosts the TechCraft Show, where people actually chat technology while playing Minecraft. And she also hosts the Cloud Native Live. And so with that, we'd like to welcome Annie to the Azure Cleveland User Group. Welcome, Annie.
Awesome. Thank you for having me.
You're very welcome. Thanks for being here. Let me go ahead and make you presenter.
Yeah, perfect. And let me be careful about sharing the right screen. That's good. Looking good. Perfect. I'll kick us off then. Thanks for everyone joining in. Very excited to be talking about two of my favorite topics, or three of my favorite topics, MLOps, DevOps, and Kubernetes. I kind of count DevOps and Kubernetes somehow in my Kubernetes world being very close to each other and similar, because obviously they are kind of together in some ways, but these are my favorite topics, so very excited to share about these with you today. And let's get started. I will be focusing, I think, on my screen, so if there's any questions, someone can unmute and, holler at me and say the question out loud. Probably won't be seeing the chat or anything like that. Good. So let's get started. So MLOps, DevOps, Kubernetes. We're going to be going through what are all of these essentially. Well, not all of them fully from the kind of basics, but some of these things from the get-go, and then we're going to be covering how are these related to each other, why and how all of these things work really well together. So let's kick us off. So the session will be about that. So it will be the intersection of all of these three technologies, areas, tools in your toolkit, essentially in some ways as well, that you can use within this time. Now I have an agenda coming up in a second, but before that, we're going to do some housekeeping in some ways. Now, I think we all know, or we can at least understand or hear, the business opportunity of AI is really happening. So these statistics are from the Microsoft AI study that was released during last Microsoft Ignite. So this is specific to from Microsoft and Azure and AI perspective particularly as well. And we can, I think, as technology professionals, we can hear that everyone's kind of thinking about these solutions, Gen AI, MLOps, all of these things, and it's up to us as tech professionals then to figure out how do we actually do these things, how do we make an impact, and if your manager comes up to you and says, "Hey, what about these new technologies? What do we do with them?" So this is essentially a session that helps you maybe orient yourself into the MLOps world if you are thinking about learning more about it, or you already decided to learn more about it and you want to kind of know what's up and how does it relate to DevOps, MLOps, Kubernetes, all of these together. Now, then a bit about me. There was also already a lovely introduction to me, so I won't be spending too much time on here. But I am the CEO and founder of my own company called Vevo, CNCF Ambassador, Azure AI Platform MVP, which essentially in a nutshell just means that I love sharing what I know in these kind of events, for example, meetups, conferences, and so forth. So that is also why I'm excited to be here today talking to you. I also been organizing a Kubernetes and CNCF meetup since 2017. I coach early stage startups, and a TechCraft Show was already mentioned there actually, which is a lot of fun to record for sure. I've also been in the KubeCon CloudNativeCon program committee for many years, so very much a background in cloud native and Kubernetes and containers specifically. And now for the last 1 to 2 years, I've been diving more and more deeper into AI, MLOps, and all of these topics. But that's my background essentially. Now we have some things on our agenda for today. So introduction going on. So we're well on the way there. We have some definitions. I don't think definitions are necessarily the most fun thing ever, but let's just breeze through so that we understand a couple of the most important ones for understanding this session properly. Then we're going to be talking about why is AI or ML different. So how does it differ to traditional software engineering? Then talking a bit about Kubernetes and MLOps, Kubeflow, best practices, considerations, wrap up on resources coming right up after that. So there's a host of fun topics here to be covered. So then for a bit of extra fun, we can kind of see that here is a pirate map or like a treasure map, where...
Excuse me, is it just me, but your screen isn't rendering? It's looking very weird.
Is everyone else experiencing the same?
Yeah, I'm seeing it just fine.
Okay.
I see your screen.
Okay, sorry.
No worries. It's good to call out it. If it was happening for everyone else, it would be really good to fix it so that we could get starting. I hope it gets sorted out for you, though. So, but at least I guess it's going to show up well in the recording. So that's going to be an option then, at least latest. Cool. So we have the pirate map for fun here. And obviously in our little pirate and treasure map, our end goal is scalable and reproducible generative AI workflows, or obviously MLOps, AI in general, or Kubernetes and all these things working together. So essentially making good technical solutions for AI and MLOps. Now, to follow us on our journey, we have a little robot here that we're going to be kind of traveling through this agenda here. So we're going to start off from the treasure, from the pirate ship, and moving along to the treasure. So first we're going to move to the jungle there for the definitions. So AI, data science, and more. So I think, as I said, definitions are not the most fun part, in my opinion. And I think most of us have already heard a bit about like, okay, what does AI mean? It means the simulation of human intelligence in machines. And then we know that machine learning itself is the development of computer systems that are able to learn and adapt without the following explicit instructions on the other hand. So you use algorithms and statistical models to analyze and draw inferences from patterns in data. And then data science is the field that uses various techniques, algorithm processes, and systems to extract insights and knowledge from the data. So these are all kind of obviously affecting each other. So you have AI, which is the simulation of human intelligence, and you have machine learning that adapts and learns from the data without explicit instructions. That data science then obviously supports machine learning with that data. Then important things for this session, or like specific things regarding this, DevOps, which is probably a term that most people here will probably know. So it's development and operations, is a cultural and technical framework that includes software development with IT operations practices. Now, the interesting part is the relation of DevOps and MLOps, which is essentially why I want to cover these definitions, because MLOps is obviously a newer term because AI has become such a big boom recently. So it's becoming more and more relevant to technology and society in general. So it is this set of practices, principles, and tools that combine the machine learning with the practices of DevOps. So if you are a DevOps professional or you know some DevOps best practices, you already would be using a lot of those in the MLOps world side of things. Now, as with every emerging discipline, obviously things are going to develop a lot. MLOps itself still leverages a lot of the DevOps practices, but as time goes on and we learn more and more, we're probably going to get even more specialized MLOps best practices and learnings that we can then utilize going further. So obviously, everything is moving, as always, in tech, for sure. Now, definitions handled, so our little robot can move the next part, which is the mountains, which is the why is AI at ML different from quote-unquote traditional software engineering. So what does it actually mean? So going from research to production. Now, I think in a very colloquial or like in a non-MLOps environment, you might think that the research portion of AI might actually take quite long compared to even the production. But actually, the research part is usually the quickest part, which might not be surprising if you are familiar with DevOps and going to production in a, regular software engineering as well. So the research portion, so developing the AI models and so forth, might actually take just a couple of weeks because it might be one person, a couple people on their own machines using just, local devices and so forth. But then going from that to production, that's where the big hurdle comes in. This usually might take months in a large team with developers, scientists, data engineers, subject matter experts. So that's essentially where the kind of trouble starts usually. So I think the number is about 80% or 75 or 70 of models never make it to production, never make it to practice, never make it to actually providing any value. So we know that, okay, well, particularly right now, going to production, the MLOps side of things is actually the bottleneck and the part that probably needs a bit more work to be done in the coming years compared to the research and model development is always important, but there is a bottleneck there and we need to kind of, focus it on a bit. So why is it then so difficult? Why do so many things fail when they're going to from research to production? And what does it mean? And how does it differ from regular software engineering? So machine learning, AI, MLOps, these are all very data-centric. So the quality and the quantity of the data significantly impacts the performance of the models. So this means that ML and AI engineers need to focus on data collection, pre-processing, and feature engineering, which are not as central in traditional engineering. So this is essentially where a big difference comes in. So you really do need to focus on the data side of things. This leads to and kind of affects, and also models are very complex. So in regular engineering, systems are typically designed and built according to well-established principles and specifications. The industry has been going on for a bit, but also it's maybe a bit more simpler sometimes. So model complexity plays a part there, because ML and AI models are complex and their behavior is learned from the data. So engineers must experiment with various model architectures, hyperparameters, and training data to optimize performance. Now, this makes iterative development and the data aspect of it super important as well, because the development is highly iterative. So engineers must continually experiment, fine-tune models, and retrain them to achieve desired outcomes. So traditional engineering projects tend to have more predictable and linear development processes. So the iterativeness brings a challenge as well. So I've talked now about complexity, a lot of data, scalability comes hand in hand there, because ML and AI solutions often require really scalable infrastructures to handle large data sets and computational demands. So that's another challenge. So it might involve usually distributed computing frameworks, GPU clusters, and cloud-based resources. Traditional engineering may not have the same scalability demands. I think we might have all noticed or heard about the big data center investments that are happening and the GPU investments happening in this space because of these reasons. And obviously, everyone might have seen the NVIDIA stock price skyrocket for sure. Now, Because of all of the data, you have monitoring and adaptation as a challenge as well. Because of the data, ML and AI systems require ongoing monitoring to detect issues like model drift, data quality changes, or shifts in user behavior. So engineers must build systems that can adapt to these changes in real time, whereas regular engineering systems may not need such dynamic adjustments constantly. This is all obviously then testing and validation. It's just compounded effect of, all of that complexity, all of that data coming in, so that testing and validation, it becomes a bit tricky. So in normal scenario, it can be based on established standards and specification, for example, as well. And in ML and AI engineering, testing often involves evaluating model performance against specific metrics. So the validation might require domain-specific expertise and may not have a clear-cut pass-fail criteria. For example, in the case of LLMs, for example, if you would have questions and answers that require medical knowledge, for example, that is obviously domain-specific expertise that developers or the developers of the systems don't have. So then obviously you need to involve a lot more people, as well as the gray zone of what is a correct and what is a non-correct answer is quite a lot trickier. Explainability and bias might easily be ignored, not ignored, but particularly it is actually very important. So understanding why an AI model makes a particular decision is really crucial, especially in critical applications such as healthcare examples that I mentioned, or finance. So AI engineers really need to address model explainability and bias, which might not be, I don't know, not always, as prominent concerns in traditional engineering. So you really do need to kind of pay extra attention there and focus on that. Now, all of this change that I was talking about obviously leads to rapid advancements in the industry. So all of the new techniques, libraries, and tools that emerge regularly is gonna, add on to the list of challenges that is happening in the MLOps, war rooms, and engineers need to stay very up to date with the latest and greatest what's happening. And I also kind of mentioned the healthcare, finance, stakeholder work there. So collaboration, particularly interdisciplinary collaboration, it can be tricky. So ML and AI projects often require close collaboration between data scientists, software engineers, domain experts, and infrastructure engineers, for example. So this is sometimes a bit tricky. And it always is a bit silly, but quite often, even the most challenging technical issues might be overshadowed by pure human-to-human collaboration issues. So another one that causes some traction sometimes. Deployment challenges. I've talked so much about scale, complexity. You can see that it's gonna be some challenges there. So going into production is tricky. So you have to really make sure that your models are served efficiently, can handle real-time requests, and integrate with existing systems. So there's a lot of there to work on, and cost cannot be underestimated either. So ML and AI infrastructure can be really costly due to the specialized hardware requirements and cloud resources, so the GPUs, for example, and you really need to pay attention to cost because no one wants to go bankrupt, that's for sure. Okay, so now our little robot has handled why is AI and ML different from quote-unquote regular engineering. So we can hop on to more into the Kubernetes and MLOps side. Now, Kubernetes is a great starting point, the base layer for MLOps, essentially, a compute and everything. So that is a good match there. Why is it a good match? So Kubernetes itself is an orchestration platform that helps you orchestrate containers and manage scale, which I already talked about a bit. But why does it actually work really well? So there's a couple of different sides of Kubernetes that work particularly well for ML and AI workloads. So portability is one. So Kubernetes provides a consistent and portable platform for running machine learning workloads. So ML models and their dependencies can be containerized, for example, using Docker, so that it makes them highly portable across different Kubernetes clusters and various, cloud providers and on-premises environments, if that's what you have going on. And you can develop and test ML models in one environment and seamlessly deploy them in another one without worrying. And it also simplifies the process of migrating ML workloads to different cloud providers and whatnot. Customizability is another one. Kubernetes is highly customizable, so you can tailor the infrastructure to your specific ML needs. And you can configure resources, networking, storage, and security settings to your liking. And it helps you and gives you a fine-grained control over resource allocation so that your ML models receive the appropriate amount of CPU or GPU resources, so you can really manage that. And you can set up custom environments and configurations and different stages in your ML workflow. So that helps out as well. Performance, Kubernetes, I think, is known for scale, performance, all of these things. So Kubernetes is, for example, just basic horizontal pod auto-scaling, allows ML workloads to automatically adapt to varying levels of demand, which is a good thing already. And then efficient resource management minimizes resource contention so that your models receive the necessary compute. So that is also obviously really great. Kubernetes is also highly consistent. So it simplifies the reproducibility of ML experiments and reduces the risk of disparities between development and production environments. And you can rely on a consistent platform for model training, serving and monitoring, and improving your operational stability. Microservices. So Kubernetes supports microservices architecture, so you can break down your ML applications into smaller, independently deployable components. And it really benefits you by giving you modularity and flexibility in ML workflows, making it easier to update and scale individual components. And you can use microservices as building blocks essentially and orchestrate from there, so you can really enhance the flexibility and maintainability there. Kubernetes is also composable, so it allows you to compose and orchestrate ML components and services into end-to-end ML workflows. And you can define, share, and reproduce ML workflows as code, or integrate various components like data preprocessing, model training, and so forth. Now, I have a fun little portion of Kata here. Kata isn't itself like specifically purpose-built for machine learning or AI, but it's a nice side of Kubernetes that helps you out with scaling. So Kata is Kubernetes event-driven auto-scaling. So it is event-driven scale controlling that can run inside any Kubernetes cluster and can monitor the rate of events to preemptively act before CPUs are affected to begin with. So it's really nice and easy in that way. This is because default Kubernetes scaling is not really well suited for event-driven applications, and Kubernetes is more for resource-based scaling, so CPU and memory itself. So this is exactly where Kata comes in. I have a quick demo because I wanted to have a quick demo here on Kata. Specifically, we're going to be doing scaling .NET Core Worker with Azure Service Bus. You can see a bit of the demo architecture there. So you have the order portal, order processor, Azure Service Bus there, order generator. So you can just imagine that this demo is essentially, let's say, a web shop that gets a bunch of orders at the same time. And then you need to obviously activate and deactivate scaling so that things go well. Perfect. Let's hop on to the other side of things here so that we can actually do the demo. And if I can get my everything working nicely, it's going to be great. It's the typos. I'm always worried about the typos even more than the demo working per se. So here we go. So we are gonna get our external IP so that we can see the demo actually. It's a bit wonky in size, but it's all good. So you can see here we have the number of messages, we have the order queue there, and soon we're gonna start seeing it being populated a bit more. So then we should go here and to see to the a bit more visibility. So in here we see the order processors, how many of them are ready. And then we are gonna grab a bit more visibility still because we want to see properly what's happening in the demo, because that's the fun part of the demo. So here we have the status of all the order processors. So how many of them are being provisioned, for example. Now, then we're gonna kick off the actual demo. So .NET Run, I've done this for the first time in KubeCon, which is why the project KubeCon is the name of this. So it's gonna tell us, let's queue some orders. How many do you want? Now, this is usually when I ask the audience, does anyone have a wish for how many orders do we want? Maybe between 100 and 150 would be a good number to add here. Anyone have a number, favorite?
Let's go for 125.
That sounds good to me. 125 orders coming in. There we go. Let's put them all in. So we're queuing an order for bike, chicken, pants, all of these things. They're coming very fast. Keyboard, table, computer pants, everything happening at the same time. And we can see that the number of orders is peaking there. It's coming, I think it's about 125. So now we need to start handling all the orders, and Kata should be kicking in to handle all of those orders. If the demo doesn't work, there we go. Oh, I had a bit of a tiny heart attack there if things wouldn't work, but we can see them actually starting now. So we have pending, container creating, running. We have order processors 1 out of 1 ready, and now we're already at 1 out of 4, so it's scaling up to 4 right now. And we are still creating more, and we are now, as you can see, starting to handle the queue. So we're kind of managing all those orders. And then you can see here that we are at 8 out of 8 of order processors already. So we are moving quite nicely into handling the orders. Usually it caps at like 10 out of 10, and then you can see that we are under 50 already, so the orders are being handled. And now it's switching from creating to pending to just simply running, because we are now at 10 out of 10. And as you can see, the order queue has been handled, and Kata has done its job and auto scaled up, and now it's gonna start eventually auto scaling down. Can tell you already that it's going to take a couple of minutes for it to start auto scaling down. So if you remember, we can go back to this demo later on. But to be honest, it's not super exciting, because it's just going to say, resources, destroyed, deleted, whatnot. So it's much more fun when the auto scaling happens rather than the auto scaling down, even though obviously scaling down is more important for cost, for example. So it's interesting and important, even though it's not as exciting to see in the demo environment itself. But that was Kata, and that was an example of Kubernetes in action, or like, to be honest, Kubernetes cloud native projects in action. So Kata is a CNCF project, a graduated project within the Cloud Native Computing Foundation. So that is an example of Kubernetes management and how it handles scale and scaling really well, for example. Moving on then to another CNCF project called Kubeflow. So Kubeflow is a CNCF project, and first, before we go there, we have some other projects that you can kind of check into. So we have Argo, Prometheus as well, that are kind of fan favorites for using from the CNCF Cloud Native Computing Foundation, or the Kubernetes Superpowers K8 SPGT, essentially. So you can tap into a lot of the different projects from the Cloud Native Computing Foundation. Kubeflow is, on the other hand, the machine learning toolkit for Kubernetes. So it's a project, an open source project within CNCF. So it's an open source platform that's designed to make it easier to deploy, manage, and scale machine learning workloads on Kubernetes specifically. So there is a lot of, obviously, products for end-to-end machine learning in general, but Kubeflow is a open source Kubernetes specific one, if you're going to look into that. So what is it actually, and what does it, all of these things that I sent here. So what does end-to-end ML workflow actually means? So that it means that it offers a unified platform that covers the entire machine learning workflow, from data preprocessing and model training to deployment and monitoring. So the ecosystem then reduces the complexity of managing different tools and components separately. It also helps with scalability and resource management. So you can leverage Kubernetes' orchestration capabilities. So Kubeflow enables the easy scaling of machine learning workflows. So you can dynamically allocate resources based on demand and optimizing hardware utilization and improving performance. It also helps with reproducibility and collaboration. So Kubeflow's infrastructure encourages best practices for reproducibility by capturing metadata, environment details, and code versions associated with each experiment. And this really helps with the collaboration aspect. So you can see that all of the issues that I kind of went through before, why is AI and ML really difficult sometimes? These kind of end-to-end machine learning platforms really aim to help with those pain points and manage that really well. Now, what are the kind of different sides of Kubeflow? So there's notebooks, for example. So it includes services to create and manage interactive Jupyter notebooks. You can customize your notebook deployment and your compute resources. It has TensorFlow, model training, model serving, pipelines. So you can use Kubeflow pipelines for rapid and reliable experimentation. You can schedule and compare runs and examine detailed reports on each run and so forth. So there's a lot there for sure. And Kubeflow is very much, as all CNCF projects, built on community and open source. So you can even get involved with the project itself and contribute to Kubeflow as well. So how does it then look like? I actually have later on the MLOps kind of life cycle a bit more complete there. But for this, essentially, you have the different phases. So identifying problem, choose an ML algorithm, experiment with data, model training, tune the model, then production phase, transform data, train model, and all of these things. And then when you add Kubeflow, you add all the different products and projects and everything. You can tap into that end-to-end workflow to really help it out. Now, if you're thinking, oh, that sounds really good, what are actual real-life examples of these being used in the real world? Well, I think one of my favorite examples is Shell. So Shell had a keynote in KubeCon plus CloudNativeCon a couple years ago now, still very relevant. It's a quick, I think a 10-15 minute keynote where they talked about how they manage machine learning with Kubeflow itself. So obviously, Shell, big company, a lot of global data, a lot of people, all of these things, and they had a lot of the same challenges that I spoke about in the beginning of the session. So they had particularly challenges with disparate and inconsistent dev environments. So creating proper dev environments was tricky, and there was a lot of local data, and using local data that was kind of okay, but using the large sets of data from global resources, it became tricky. Then there was a lot of requirements for specialized skills. So expecting data scientists, for example, to learn Kubernetes, to do things and manage things, it gets a bit hairy. It gets tricky. And they also had a lot of wasted and underutilized resources. So cost, essentially, a big consideration there. So Kubeflow helped them with securing cloud hosting and self-service, so they could do rapid onboarding at scale. They could use a self-service model, so data scientists, for example, can grab computational power and use pre-configured settings, so they wouldn't have to learn everything from scratch. So what used to take for onboarding weeks and months, now they could do just in minutes, essentially. So there was a lot of benefits from there. And they also have managed to share cloud resources. So the accelerated model training and deployment, and you can monitor notebook servers and see how much compute they're using and release, importantly, the compute if needed. So that's essentially one of these benefits that Kubeflow brought there. So now we handle Kubeflow. And if you are interested in the keynote, obviously you can just memorize the name from there, but I do have a link to it at the end of the presentation, so don't worry. So now our little robot can move on from the little jungle, and obviously there's the school area, whatnot, still left to cover, but we can move on to the mountains next. So I mentioned a bit about that, I have the stages of the automated ML pipeline coming. So here it is. I made this specific image for the AI tour in New York, Microsoft AI tour in New York that happened, a week or two ago. So that is specifically an example using all Microsoft examples and Microsoft stack. So I don't have the kind of, Kata examples or whatnot here. But I think it's very fitting for an Azure meetup, by the way. So this is all from the Microsoft stack, essentially. So what do all of these different phases then mean? So, well, you kick off from there, from the development and experiment phase. So you iteratively there try out new ML algorithms and new modeling, and then you see where the experiment sticks are orchestrated, and the output of that stage is the source code of the ML pipeline steps that are then pushed to the source repository. And in there, you would, for example, in the Microsoft stack, you would use Azure ML, or Azure ML is an end-to-end machine learning platform as well. So Kubeflow is another thing that you could obviously use across the life cycle as this, but also Azure ML works really well as well. Then moving on to the next one, which is pipeline continuous integration. So you build your source code and you run various tests, and the outputs of this stage are the pipeline components, so packages, executables, and artifacts to be deployed at the later stage. And for example, for this stage, you could use Azure DevOps to manage this. And then at the next phase, which is pipeline continuous delivery, so you then deploy the artifacts produced by the CI stage to the target environment, and the output of this stage is then deployed pipeline with the new implementation of the model. GitHub could be a tool that you use here. And continuous training or automated triggering would be the next step here on the right side. So the pipeline is automatically executed in production based on the schedule response trigger. So the output of this stage is the trained model that is pushed to model registry, and obviously new data would be added here. And I have here Cosmos DB working as the kind of new data pipeline there. And there you would do model continuous delivery. So you serve the trained model as a prediction service for predictions, and the output of this stage is deployed model prediction service, which you would use, for example, AKS meaning Azure Kubernetes service, so Kubernetes in this phase. And then at the end, quote unquote, there is monitoring. So you collect the statistics on the model performance based on live data, and the output of this stage is the trigger to execute the pipeline or execute the new experiment data cycle. And obviously Azure Monitor would be a good tool to use for the monitoring stage, but it's essentially a cycle, a never-ending cycle that just continues and optimizes, and that's how essentially things would be run. Hopping on to the next area here, so a bit of more best practices. There was a couple of tooling examples there from the Azure stack, but what are some of the best practices that you have to kind of overarching frameworks that you have to keep in mind? The session name kind of has it already. So MLOps, hard DevOps. So, and I mentioned it at the beginning, so you can tap into a lot of the different MLOps practices by using your knowledge in DevOps already. Understanding bottlenecks is highly important. So figuring out in what stage of that life cycle that I just showed, where are the different bottlenecks, where are the issues that you're facing, where can you kind of start fixing things. Also, up-leveling your skills is usually a thing that people might have to consider when they're getting into MLOps more, because it depends all on your background. For example, I have a container and Kubernetes background, so I don't have to work as much to learn those areas. But if you are a data scientist from a data background or anything like that, you might have to learn a bit more on that phase. And then on the other hand, for me, obviously, or people of container and Kubernetes background and these kind of things might have to more learn about data management and so forth. And just, Python and whatnot, or even just like basic math sometimes might be needed, because these areas kind of, you have to learn new skills. But honestly, across the board with ML and AI, it's all always in the data. Like that's really it. The bottom line is there. So that's really the thing to remember, training data and fixing it essentially. So now if everyone would be new to DevOps, obviously tapping into those practices is super important. I've kind of spoken a bit about them via the tooling that I showed here, and I'm not going to cover this slide fully, but I think we can all kind of really remember to use like the basic principles of DevOps. So, automation is important. So automation of repetitive and manual tasks through the software development process, continuous integration, so CI/CD, continuous delivery as well. So automatically deploying code changes is super important. Monitoring, well, I've spoken about it, that it's even more important because there's so much data coming in. But it's always all of these things. And obviously you cannot forget security, always important. So really focusing on that is also highly important, of course. Now, we are not going to, as I said, cover that slide fully because I think DevOps practices might be familiar to people. If not, obviously, there's a lot of material that you can tap into to learn more about those. So then, now we're at the mountains here with our little robot, and we could be going on to the end, but we're actually going to go to the school area, aka the spooky considerations, which, if you kind of think about it, it's kind of clear that it's ethical considerations. So I think ethics, fairness, bias, all of these things, so highly important in AI and ML development. I mentioned it already in the beginning, but there's actually a lot of really interesting and important things that you have to consider from different sides, which obviously are important in traditional software engineering as well, but might not be as crucial in some ways as it is in AI and ML. So you really do have to address bias in data and algorithms to ensure fairness in ML and AI systems, because biased data can lead to discriminatory outcomes and reinforce existing inequalities. So you really do have to think about these. So you can regularly audit data for bias, implement bias mitigation techniques, and strive for representativeness in your training data sets. And obviously, fairness and bias just also means that if you are not monitoring for this, you will just have bad results, because it's not even about like political fairness or bias. It's simply about, like, is your data sets actually correct, and are you actually producing results that matter to your users, essentially. So it is very, very important. So transparency is important as well. So it's critical to building trust in AI systems as well, obviously. So users and stakeholders should understand how AI decisions are made. So you can help with this by documenting your model architectures, data sources, and decision-making processes. And if you're making these solutions, really documenting them and via providing them internally, for example, in the organizations. So that might help people to understand how these things work. And you can implement explainability techniques to make AI models more interpretable as well. Privacy is important as well. So you have to respect user privacy by protecting sensitive data. And you must obviously adhere to privacy regulations as well. So you can implement data anonymization, consent mechanisms, and data access controls and protect user privacy. Now, there's obviously a lot of different regulations as well that you have to consider. Accountability is a big one as well. So consideration there is that developers should ensure that AI systems are accountable for their actions. So you have to understand who is responsible for AI decisions and how do you manage that. So you can establish clear accountability frameworks, conduct regular audits, and document the roles and responsibilities of AI system owners and operators as well. Consent and user empowerment is important as well. So users should have control over the interactions with AI systems. So obtaining informed consent and providing options for user empowerment are important. So clearly communicating the capabilities and limitations of AI systems to users, offering opt-in or opt-out features is also really important and good. Security, mentioned it already before. So implementing robust security measures like access control, encryption, and regular security assessments is important and good, and just a plain old good traditional software engineering principle as well. Human-centric design and thinking is also really good. So prioritizing human well-being and safety when designing AI systems, and ensuring that AI complements human intelligence rather than replacing it. So you can really help with this by taking action, like involving multidisciplinary teams, including ethicists and domain experts, to think about these things with you as well. Data governance is important. So you should establish responsible data governance practices. So data should be collected, stored, and used ethically and securely. So you can implement the policies, assess data provenance, and adhere to data handling best practices. And obviously, just stopping occasionally and thinking about the long-term consequences of the software or the projects and the products that you build. So predict and mitigate the potential negative impacts that are happening. And then obviously regulatory compliance is important as well. No one wants to get caught, or you don't want to get caught, or you don't want to do anything that would be, against regulations or laws either. Now I am about to kind of soon to be wrapping this up. So if you want to learn more, here is a slide that I had in the AI tour, Microsoft AI tour for New York. Now, if you're looking for Azure-specific resources around MLOps. So you can tap into, I have here this workshop, like a full, this is by one of the developer evangelists for Microsoft. So it's the Contoso chat from Nitya. So highly recommend checking that out. You can actually do it as a self-managed workshop, build it, step by step, follow it out. I have the Qflow keynote here linked, and then some of the products that I mentioned in the image of a MLOps lifecycle. So Azure ML, Cosmos DP, AKS. And now, if you want a longer explanation into different sides of MLOps lifecycle, I have a resource called Example Basic MLOps Flow. Here, this is not an Azure specific. You can already see the AWS Lambda there, but this is a really helpful resource if you're trying to understand more. And the link to that one I have here. So end-to-end MLOps basics. It's from the MLOps community, which is a great YouTube channel to check out in general if you're looking to learn more about MLOps. Here is the Qflow keynote again. And if after this session you're thinking, man, that was a really good session, I liked the learnings, but I would have wanted to see more coding examples or step-by-step guides into how to use these products. Well, the Practical MLOps book by Gift and Deza is actually really good. It's from O'Reilly. It is a couple years old now, so I hope they come up with an updated version as well as sometime, but it has host of practical examples. Well, that's in the name as well, so that's really helpful there. There's really good MLOps automation with Git-based CI/CD as well. And then Kubernetes AI Day, it's a side event or like an event within KubeCon plus CloudNativeCon that happens every time there's EU and North American one at least. They have a really good, the state of production of MLOps in cloud native environments by Alejandro session there. So that I highly recommend, or to be honest, all of the Kubernetes AI if you want to dive deeper into Kubernetes and AI specifically working together. And as a preemptive shout out, I can say that I'm speaking at the next Kubernetes AI Day in London that's coming up in a couple months, and I will be specifically speaking about AI and Kubernetes security then. So after that finishes, even if you're not in London, all of the sessions will be added for free to YouTube, to the CNCF YouTube account. So you can always tune in there. But as you can see, we are finished with our agenda and we are at the end of here. So our little robot can go to the treasure. X marks the spot and we can, be happy. We find the treasure of, why MLOps, DevOps, and Kubernetes all works together, and we can really build scalable and reproducible AI and ML workflows. So we can be happy and be happy with this. And just for fun, I have here a couple of AI and ML memes to wrap us up for today. I hope everyone had a good time, and I guess we have some time for questions now.
Yeah, so if anyone has any questions or comments, feel free to come off of mute or enter them in the chat window.
Yeah, and also if anyone doesn't have a question right now, but you're gonna, waking up in the night later on being like, oh, damn, I should have asked X, always feel free to send me a LinkedIn message, happy to help, or at least point you to the right resources if I don't know the perfect answer right away.
One of my favorite platforms, LinkedIn. Great way to connect with others.
Exactly. I do like LinkedIn.
I'm curious, will you be making the slides? Could you send them to me and I can share them with a group? I can
yes.
put them on my blog.
Yeah, I can I can send them to you, and then I can add them to my GitHub as well. So you see here is my GitHub link. So there I will add them there. There is already a version of them there. But I think I always make updates and whatnot. So I'll add like a new version as well, and I'll send it to you as well. So don't worry, we can get them there.
That's perfect. Thank you. And speaking of links, there's actually a few links that I posted in the chat window for everyone that we'll be covering in just a second. But wanted to give you one last chance to ask any questions or provide any feedback to Annie. And if not, if I may, I'd like to share my screen to present some closing slides.
Sounds good.
But before I do, I wanted to thank you, Annie. That was very informative, covered a lot of territory there, and the links are definitely very useful. We'll definitely be looking more into that.
Good.
thank
Happy to hear that it was good.
Appreciate it. Let me go ahead and share. All right. So within the chat window, there's a few links. First, there is the link for the YouTube channel. If you would please subscribe to that so you get upload notifications. It's going to take a couple days just to edit the video, and then it will be posted online, as well as with the link to Annie's GitHub. In addition, tech events are also posted on my blog, samnasser.blogspot.com, and you can also subscribe to that to get updates as they are posted. Last but certainly not least, the form for the feedback eval. Please take a few minutes to fill that out so it can provide Annie with some constructive criticism. If you're in the job market, I invite you to check out devitjobs.com, a very interesting website that allows you to narrow your choices, either working remotely or in person, the type of technology, the geographical location, et cetera, et cetera. All that can be found on devitjobs.com. Lastly, my contact information, my email, should you have any questions or need to get in touch with any of our speakers, either Annie or any of our previous speakers, feel free to reach out to me, snasser@nistechnologies.com. In addition, you can find all my social links, including the YouTube channel, all through Linktree. That's Linktree/Sam Nasser. And my favorite platform, LinkedIn. Great way to connect and keep in touch with everyone and see what they're working on, as well as any articles that may be posted and shared. So if we're not connected on LinkedIn, please, let's do so. And so with that, thanks again to Annie, and thanks for everyone that attended. And we look forward to seeing you at next month's meeting. Good night, everyone.